This is Physical Science 2, Chapter 7, Part 2, on the Sun, Moon, Earth system. In this portion of the video lecture, we will be discussing time and seasons. Now, today in the 21st century, we're very busy people. We need to know what time it is because we have appointments to keep, we have school to go to, we have things to go, places to see, people to meet. And so we need to know what time it is. However, before technology, before the ability to have a timepiece, keep your time, observation of time and seasons were the only method to measure time. And generally speaking, the only reason why you and I care what time it is today in the 21st century is because many thousands of years ago, ancient peoples needed to know what time it was so they could party. They needed to know when to have a good old throwdown celebration to plant crops, to harvest the crops, perhaps different events in their tribal calendar that they developed. They would need to know when to please certain gods or goddesses or different aspects of the earth or the sky or whatnot. So people care about time today because ancient people needed to know when to throw down and party. Of course, now our lives are a lot more busier than just being able to throw down and party at certain times of year. But generally, the very first observations of time, again, were done with the ultimate human tool of the eyeballs. Our movements measure time. The Earth spins around a full circle, 360 degrees, in 24 hours. So that is what we consider a day here on Earth. And so every 1 hour that passes through our 24-hour day, the Earth completes 15 degrees of its 360-degree revolution. And so that is how we develop our time zones. So a time zone is an area roughly 15 degrees wide where the time is the same. So everyone within that same time zone will have the same time on their watch. Now you'll notice from the world map here that not everybody participates in what's called daylight savings time when we put the clocks back or ahead. And you'll notice that most of those countries are very near or on the equator. Not participating in daylight savings time allows people in those regions to not have to suffer the dreaded heat of the daytime any longer than they need to. Currently, the only state in the United States that does not participate in daylight savings time is Arizona. Also, you'll see from the map that not every 15 degrees, it's not a fully marked area. Some of the time zones are a little wider. For example, all of China is on one time zone. That just keeps it easier, especially nowadays for worldwide transportation, that roughly one country should be in the same time zone, except for the instances, for example, of the United States, where we can, and Canada, where we can roughly split ourselves, and it still makes sense. So where does time start? I mean, we have to have a 0 hour, right? Well, the starting point for what we call coordinated universal time, or world time, is the international dateline. So this is kind of the start point of where we measure our one day to the next day. Now, the international dateline is way out in the middle of the Pacific Ocean. Again, it's not a perfectly straight line. We want to make sure that, for example, in between Alaska and Russia and the Bering Sea there, that we're not cutting out part of Russia and putting them on a different day than their neighbors a few miles down the road. So generally, this is where we start our clock for time and time zones. So the Earth's rotation, again, we spin around once in 24 hours. So a rotation is the spinning of Earth. We do that on what's called the Earth's axis. The Earth's axis is kind of an imaginary line, if you will. If you could punch a pole right through the magnetic North Pole and have it punch out through the Earth all the way through to the magnetic South Pole, that would be what we consider our axis. It is tilted, which is going to clue us in a little bit later here on why we have seasonal changes. So how do we measure a day? Well, believe it or not, a solar day is the sun's movement from noon one day to noon the next day. So you can try this at home with your parents, although it never worked with my parents when I was younger, that technically the day does start at noon. So on Saturdays when I would like to sleep in, my mother would say, "You need to get out of bed, it's almost noon, half the day is gone." Well, technically the day starts at noon. Like I said, you can try that one at home, although it will probably go over as well with your parents as it did mine. But we measure a solar day from noon to noon. The time it takes for the Earth to orbit around the sun in its elliptical pattern is a revolution. So our period of revolution is 365 days or 1 year. Now, before we have, again, modern technology and things like atomic clocks to measure our time, in observations of the time that it takes for the sun to complete one trip through the sky in reference to a background of stars, that's what we call a sidereal year. Ancient peoples would kind of put their calendars around a sidereal year because, again, they could chart the sun's progress through the sky and see at night and compare at nighttime what those stars look like. And they could calculate roughly an entire calendar year. So why do we have seasons on the planet? I can tell you that it is a very common misconception that people believe that it is hot in the summertime because we are closer to the sun, and it is colder in the wintertime because we are farther away. That could be no farther from the truth. Our seasons do not change because we are at different distances from the sun at different times of the year. Our seasons change because of two things. The number of hours of daylight each day varies throughout the year, even without daylight savings time. We would notice that generally in our winter months, days are shorter than they are in the summertime months. Also, the angle at which the sunlight is striking the surface is a key to season change. And that angle is because we are tilted on our axis. The Earth does not, in its position to the sun, is not perfectly vertical all of the year, so we are tilted 23.5 degrees. So part of the Earth, or the hemisphere, that means half circle, that is tilted towards the sun will receive more intense sun rays. Those sun rays will be warmer, therefore warmer weather. And the hemisphere that is tilted away from the sun gets less intense sun rays or less direct light, meaning that the temperatures will be cooler. So in this diagram here, this would be an example of our summer because we are in the northern hemisphere, so we are above the equator. We live in the Tropic of Cancer. So we have more intense sun rays that cover a less amount of an area, so that means warmer temperatures. Now in the southern hemisphere, when it's summertime here, students in Rio de Janeiro, down in Brazil, they're experiencing a winter season because they have less intense sun rays that cover a larger area. So that means lower temperatures. And just like temperature for hours of daylight, the hemisphere that is tilted towards the sun will receive more hours of daylight, and the hemisphere that is tilted away from the sun will receive less hours of daylight. So we mark our seasons by what the sun is doing above the horizon. So an equinox. An equinox is when the sun is directly above the equator. So equa means equal. equator, that's the middle part of the Earth, if you can kind of match those two first portions of those terms. So the equinox happens at the equator, and it happens in the spring and the fall. So in March, we have what's called the spring or vernal equinox. This happens around March 21st, 22nd. And then in September, we have the fall or autumnal equinox, which is around also September 21st or 22nd. So generally speaking, the hours of daylight and hours of darkness are roughly equal, but the equinox means that the sun is directly above the equator. Now, in our winter and summer months, we experience what's called a solstice. The solstice is when the sun reaches its greatest distance, either north or south of the equator. During the winter solstice, the sun reaches its greatest distance north of the equator. So this is our shortest day all year long. This happens December 21st, 22nd. And the summer solstice will happen when the sun reaches its greatest distance south of the equator. And that is our longest day of the year, and this happens around June 21st or 22nd. So in the positions of the winter and the summer solstice, when we refer in this class to seasons, we will always talk about or refer to the season that it is in the northern hemisphere, because that is where we live. This has been Chapter Physical Science 2, Chapter 7 on the Sun, Moon, Earth System, Part 2.